Okay, back to our practical use and application of our standard. Today we have 8 out of 100. This is our concrete representation. Here's our abstract representation. We have 3 of them. We have 8 out of 100. We have 8%, and we have 8 hundredths. English, Latin, Greek. But they mean the same thing, 8 out of 100. The whole has been cut up into 100 pieces, and we have 8 of them. Now, yesterday we went over the difference between factors and multiples. So what I would like you to do is I would like you to think about this and press pause. Think about what are the factors of 8 and what are the multiples of 8. Press pause now, and when you got it, continue. Okay, the factors of 8, we went over yesterday. The factors are like a factory. And the factory makes things. The parts go in, they get multiplied together, and out comes a product. Doesn't matter if they're sneakers or cars. Well, the same thing is true with math. We have a factory that when we multiply together, the answer is called a product. And the product in this case is 8, and we want to find out what are the factors that make that product. Well, I know 1 times 8 equals 8, but also 2 times 4 equal 8, which means 1, 2, 8, and 4 are all factors of 8. Now, the multiples of 8 is just your multiplication tables. 1 times 8 is 8, 2 times 8 is 16, 3 times 8 is 24, 4 times 8 is 32, on and on and on and on. But in order to use factors to put our fractions in simplest forms, we need to find the factors for the top and the bottom, the numerator and the denominator. Because like I did on the 5th day of school, we want to put them in the largest chunks possible. Because the idea, we want to make it simple. Our brains need to put things in a simple setting because our brains sometimes can't comprehend certain numbers. Like we can all understand the idea of 10 and 20 because we have 10 fingers and 10 toes. At least most of us do. But there are some things that we can't, like if we start going into the thousands or the millions, or if I say 65 parts out of 100, or later on when you're going on to things that are not percentages, where you might be going 32 pieces out of 98. When we start getting with big numbers, our brains have a hard time, so we always want to put our fractions into the simplest form that we can understand them. Sometimes our brains can't comprehend it all. Now, 28 trillion is a number that we might hear in the news. And some people go, wow, that's a lot. But how? How a lot is 28 trillion? Well, I'm going to ask you a question. I want you to press pause to think about the answer. If you had 28 seconds, how far back in time would it take you? Okay, press pause. Okay, did you think about it? In the comments section of our daily lesson plan, type in what your prediction was. How much time do you think 28 trillion seconds is? How far back in time would it take you? Did some of you say a couple hours? Did some of you say a couple days? Every year I ask this question to the kids, and I use our national debt just because it tends to be a large number. And when I ask them, some kid will throw out the number like a year, 2 years. And sometimes they do it because they want to be funny because they think it's over the top. Did you know if you had 28 trillion seconds, it would take you before the dinosaurs were on the planet? Imagine that. So we want to make sure that when we're dealing with fractions, we always want to put things in their simplest terms. So what I'm going to do today is I'm going to see if I can put 8 100ths into simplest terms. Now yesterday we had 7, and 7 was prime because it only had a factor of 1 and itself. Well, when we did this, we realized it was already in its simplest form. Now, if you're not sure if you have a fraction and you're not sure if it is, here's what you do. You list the factors for the numerator and the denominator. So my factors we already learned are 2, 1, 8, and 4. Our factors for 100 are 1, 100, 50, 2, 25, 4, 20, and 5. Okay, I wanted to erase some things so we could go right onto the application. I'm going to rewrite, however, 8 out of 100, and below it here I'm going to put my common factors that we just went over. And our common factors are 2 and 4 that we found in these two numbers. And so what I would like us to do is I would like us to simplify by dividing these common factors into both the numerator and the denominator so you can see what happens to the fraction. They will become equal values. They will become equal values, but they will become in terms of a simpler form for our brain to comprehend. So if you would like to press pause right here and divide 8 by 2 and 100 by 2, and then take 8 divided by 4 and 100 divided by 4 and look at those fractions, maybe make your own charts, go ahead and do that. I think that would be very healthy for you to see why you would either want to choose the lower or the larger number. Go ahead and do that. Press pause. Okay, this is what you should have done. Let's start with the smaller number. If I take 8 and I divide it by 2, so I'm going to take 100 and I'm going to divide it by 2. I always like to start with the denominator because the denominator is what the whole has been cut up into. And so I know if I take 100 and I cut it up into 2, I'm making 2 equal parts that equal 100. Well, how many parts now do I have in each one of these parts? Well, now I have 50 on this side and I have 50 on this side. That's why my denominator now can be 50 because I divided it in 2. So that means now I have 2 fractions of 50. Well, what am I going to do to the 8? I'm going to divide that by 2. So I'm going to take the 8 that I had up here, and I'm going to divide it by 2, which gets 4, and I'm going to put 4 on each side. 1, 2, 3, 4, and 4 on this side. 1, 2, 3, 4. And so when I divided both the numerator and the denominator by 2, I made a simpler fraction that instead of 8 out of 100, I now have 4 out of 50. But what happens is if I instead use the largest factor in our list, which is 4. 8 divided by 4 and 100 divided by 4. Once again, I start with the denominator because the denominator is what the whole has been cut up into, and 100 divided by 4 equals 25. So now I'm going to cut up the whole into 4 equal parts of 25, and you can go ahead and count them if you need to. And then 8 divided by 4, I'm going to take my 8 that I have up here, and I'm going to cut them up, divide them by 4. And 8 divided by 4 is 2. So that means I will put 2 pieces in each one of these. I can put them anywhere. I'll just put them anywhere, just so you can see that it doesn't matter, because it's 2 out of 25. And these are all, now instead of dealing with 100, now look, I'm dealing with a simpler fraction that has the same representation of 2 out of 25. Now, how do I know? And this is the point that I really want to get to. It's just a matter of just observing for right now. But just so you can see that 2 out of 25 does equal. Let me show you one quick thing. I know this is a long calendar math, but if we have 2 over 25, remember, this fraction bar is the same thing as a division sign. So I take 2 and I divide it by 25. Now 25 can't go into 2, but I told you if a number doesn't have a decimal point, you can always put a decimal point at the end. And that's how you break up a number into a tenths or a hundredths or thousandths. But for this, we're going to break it up. We're going to put our decimal point, and we are going to break it up into 100 pieces. And then the decimal point, when we're doing this, we just bring it straight up. How many times does 25 go into 2? That would be none. How many times does 25 go into 20? That would be none. How many times does 25 go into 200? Let's see. 8 times 5 is 40. And 8 times 2 is 16, 17, 18, 19, 20. 8 hundredths.